students, I hope all of you are doing good. Let's start today's chapter, geometry. Number 1, identify and write the name of the following lines. You can write the name of these lines. AB, this is AB, this is PQ, this is LG, okay. And in question number 2, you have to write the name and the number of line segments in each of the following figures, okay. Name of line segment AB, AC and BC, okay, and there are 3 line segments, okay. Looking back, let's revise what we have learned in earlier classes. Line segment. Let A and B be 2 points on a plane. The straight path from A to B is called the line segment AB. This is denoted by this sign AB, okay. The points A and B are called the end points of AB. The distance between A and B is called the length of AB. Thus, a line segment has a definite length and it can be measured. The shortest path between 2 points is called a line segment. Line. A line is an endless straight path that extends in both directions. A line has no endpoints. See this figure? The line segment AB extended on both sides and marked by arrows on both the end represent a line denoted by AB, okay. And these arrows represent that we can extend this line endlessly in both the directions, okay. Arrows on either side indicate that the line is endless. Sometimes lines are represented by small letters like L, M, N, etc. like in this case, okay. In this figure, L is a line, okay. Consider a point A. Draw lines through it. What do you observe? Okay. See, this is the point A and then you will draw lines through it. We observe that an infinite number of lines can be drawn through a given point A. However, as shown below, only one line can be drawn through 2 given points. Like these are 2 given points and we can only draw one line segment. Okay. Ray. A ray is a straight path having one endpoint and extending endlessly in one direction, okay. This, like arrow, the endpoint of a ray is called its initial point. This is the initial point, okay, and we can extend this ray endlessly in this direction. In the figure given below, AB is a ray and A is its initial point. AB, this is the sign of ray, okay. Measuring line segment. To measure a line segment, we use a ruler or scale. A ruler is marked in centimeters on one side and inches on the other. Each centimeter is divided into 10 equal parts and each part is a millimeter. Nowadays, inches are always not used. A ruler is used to draw line segments and measuring a length of line segment. Consider the following example. Draw a line segment of 5 centimeter. We proceed as follows. Place the ruler on the paper, mark a point A against the 0 mark. Remember, whenever we draw a line segment, we always start from 0. Okay, then mark point B above the mark 5. Now keep the pencil at the first point and move it along the edge, keeping the ruler pressed evenly till the pencil reaches the point B. Then we remove the ruler and pencil. We get the line segment AB on the paper and the length of AB is 5 centimeter. Okay. To measure the length of a segment, to measure the length of a line segment PQ, place the edge of the ruler in such a way that 0 mark of the ruler coincides with P. Next, read and mark the number with the point Q coincides. Here it is 6, hence the length of the line PQ is 6 centimeter. In case where 0 mark of a scale is erased or not clearly visible or worn out, we can still use the scale to measure the length of a line segment. In such case, we start the measurement from number 1 and from the measurement obtained, we subtract 1 to get length of segment. We can use a divider and ruler also to measure the length of a line segment. A divisor, this is a divisor. A divisor is an instrument which has 2 arms with 2 pointed ends. Example 1. Measure the length of the line segment AB by using divider and ruler. Solution. To measure the line segment A and B, we place the endpoints of the divider on the points A and B of AB. Okay, like this. Now, without disturbing its arm, place the endpoints of one arm at a 0 mark of a scale and then read the mark where the other end of this divider falls. This gives the distance AB. Open shapes. The shapes which do not begin and end at the same point are called open shapes. Okay, these are the open shaped figures. And closed figure, the shapes which begin and end at the same point are called closed figures. For example, these are the closed shape figures. Let's do exercise 12.1. Number 1, name the line segments in the following figure. Okay, line segments AB, AC and BC. So there are 3 line segments in this figure. Okay. Angles, types of angles and construction of angles. 2 rays having a common endpoint form an angle. This is a ray, this is also a ray, and these 2 rays have a common endpoint, this one. So this is angle. Consider the figure given below. Rays OA and OB start from the point O. Okay, this is OB, this is OA. Both rays are starting from the O. The figure so formed is called an angle. An angle is often denoted by this symbol. This is the symbol of angle. The 2 rays OA and OAOB are called the arms. Okay, arms. This is arm, this is arm. And the common meeting point O is called the vertex. Okay. Generally, we name an angle by 3 capital letters. The letter at the vertex always comes in between the other letters. Okay. In the above example, the angle is named as angle AOB or BOA. Remember, vertex should come in between the 2 letters. Okay. Or it can be named as simply angle O. Interior and exterior of an angle. Consider an angle PQR. PQR. Okay, consider a point X on rays QP and a point S on ray QR. We say that X and S lie on PQR. Okay, there is PQR, X and S lie on PQR, angle PQR. Consider points V and T in the inside of PQR and U and V lie outside angle PQR. We say that the shaded area, this is the interior of angle PQR, which can be further extended. The area other than the interior is called the exterior of angle PQR. Measurement of angles. We measure angles in degrees. A complete rotation about a point is divided into 360 equal parts. Each of these parts is called a degree. 1 degree is written as this, 1 degree. Okay. A protractor. This is protractor. An instrument called protractor is used to measure an angle. Following is the diagram of a protractor. It is a semicircle, means half of circle. The midpoint of its horizontal edge is called its central point. The angle at the center is divided into 180 equal small division, each being 1 degree. The protractor has 2 scales, inner and outer. One scale begins with a 0 on the right and runs to 180 to the left. The other scale begins with a 0 on the left and reaches 180 on the right. Right? Example 1, find the measure of angle CAB. Method. Place a protractor in such a way that its central point lies on A, this point. The vertex of angle CAB and its horizontal edge lies on arm AB. Now observe the mark on the rim of the protractor through which arm AC passes. Taking the scale whose 0 degree mark lies on AB, we find that AC passes through 60 degree mark. So the measure of angle CAB is equals to 60 degree. Okay. Example 2, find the measure of angle PQR. In similar way, you will find the measure of this angle, okay, by using protractor. Next, example 3, using protractor, draw an angle of 120 degree. Method. First, you will draw a ray, AB, okay. 2, place a protractor in such a way that its central point lies on A and its horizontal edge lies along AB. Observe along the scale whose 0 mark lies on AB until we find the 120 mark on the rim. Okay, here is a 120. Okay, we'll put a dot here. On that mark, put a dot with a fine pencil. Pencil should be pointed and sharp and name it C. Now remove the protector and join C to A. Okay, and angle BAC is 120 degree, right? Types of angles. Number 1, acute angle. An angle whose measure is less than 90 degrees called an acute angle. In the figure, angle PQR is an acute angle. Okay. Right angle, an angle whose measure is 90 degrees called a right angle. In the figure, angle MNO is equals to 90 degree. And angle MNO is a right angle. Third, obtuse angle, an angle which measures more than 90 degree but less than 180 degree is called an obtuse angle. In the adjacent figure, measure of angle WXY is an obtuse angle because it is greater than 90 degree, okay, or it is more than 90 degree. Number 4, straight angle. An angle whose measure is 180 degree is called a straight angle. Look at the figure. Angle BOA is equals to 180 degree because it is a straight angle. It is a straight line. A straight angle is equals to 90 plus 90 degree is equals to 180 degree. Okay. Exercise 12.2. Measure each of the following angles using a protector. You have to measure these angles with the help of protector. Okay. Perpendicular lines. When two lines intersect and make a right angle, they are said to be perpendicular to each other. Consider two rays BA and BC meeting at B, making an angle of 90 degree. So we write AB is perpendicular BC. Drawing perpendicular using set squares and protector. Set squares are two triangular items that we see in a geometry box. These are the set squares. The angle of one of the set squares are 90 degree, 30 degree and 60 degree. The angles of other set square are 90 degree, 45 degree and 45 degree. Example 1. Draw a line segment perpendicular to PQ at P using a set square. Procedure. Number 1. Place a set square such that the edge having 90 degree fall along line PQ and the vertex at which the right angle is found fall on P. Number 2. Hold the set square firmly and draw a line segment PR along the edge of a square perpendicular to that lying along PQ. 3. Remove the set square. 4. PR is the required line segment perpendicular at P. Okay. So try this procedure with the help of set squares. Okay. Example 2. Draw a line perpendicular to ray AB at A using a protector. Procedure. Number 1. Place the protector such that its horizontal edge lies along the AB and the central point lies at A. The 0 degree mark lies on AB. Read the protector anti-clockwise from 0 degree. Mark point C just above the 90 degree mark on the rim of the protector. Next, remove the protector and draw ray AC. We write AC is perpendicular to AB. Okay. Now, circle. In the daily life, we come across objects that are circular in shape such as bangles, coins, wheels, tires, etc. Look at the figure given alongside. In the figure, O is the center of the circle. Distance of O from every point on the boundary of the circle is same. That is, OA is equals to OB is equals to OC. Okay. The distance OA represents the radius of the circle. We consider the following facts. A circle is a closed figure, each of whose point is equidistant from a fixed point inside it. Radius. It is a line segment joining the center to any point on the circle. In the figure, OA. OA is a radius, OB is another radius. The plural of radius is a radii. Now, chord. A line segment having both its endpoint on a circle is called a chord. Here, you can see PQ. Both the points of this line segment are on circle, therefore, it is a chord. Diameter. Diameter, it is a chord that passes through the center of the circle. It is a chord means its 2 points will lie on the circle, but there is a difference that it passes through the center of a circle. So clearly, see, AB is a diameter and diameter is double of radius. So AB here is a diameter. To draw a circle of given radius, To draw a circle, we use a compass, usually found in a geometry box. A compass has two legs. One leg has a steel end, while to the other leg, a pencil is fixed by means of a screw in such a way that the pencil end and the steel end are at the same level. Example, let's draw a circle of radius of 5 cm. Procedure, open the legs of the compass to 5 cm using a ruler. Mark a point, say O, on the paper and place the steel end of the compass at the point O and turn the pencil round so that it makes a circle. Remove the compass, we get a circle of radius 5 cm. Okay. Exercise 12.3. You have to draw a ray PQ, draw a perpendicular to PQ at P using a protector, right? You will do it by yourself. Polygons. Consider the following figures. Of these, we see that figures D, E intersect itself while others do not. Closed curves which do not intersect itself are called simple closed curves. A simple closed figure having 3 or more line segment is called a polygon. The line segments that form a polygon are called its sides. The point at which 2 line segments meet is called a vertex. Okay. The plural of vertex is vertices. A polygon having 3 sides is called a triangle. A polygon having 4 sides is called a quadrilateral. A polygon having 5 sides is called pentagon, and polygon having 6 sides is called hexagon. Triangles. Consider the figure given alongside. A closed figure bounded by 3 line segment is called a triangle. In the figure, PQ, QR and RP are line segments meeting each other at Q, RP respectively. We observe that it has 3 sides, namely PQ, QR and RP. 3 angles, namely angle P, angle Q, angle R. Okay, and 3 vertices, namely PQR. The symbol for a triangle is this. Okay, so a triangle is named after its vertices. Thus, we can name triangle PQR as triangle QRP or triangle RPQ or triangle PRQ or triangle RQP or triangle QPR. Okay. Quadrilaterals. A simple closed figure having 4 sides is a quadrilateral. Consider the figure ABCD. It is a quadrilateral. It has 4 sides, 4 angles and 4 vertices. The sides are A, B, B, C, C, D and D, and the angles are angle A, angle B, angle C, angle D, and the vertices are A, B, C and D. Adjacent sides. The sides of a quadrilateral having a common vertex are called adjacent sides. In the figure, AB and BC are adjacent sides because here B is common point. Similarly, we have CD and DA are adjacent sides. Here D is the common point. Okay. Opposite sides. In the above quadrilateral ABCD, AB and DC are opposite sides. Similarly, CD and DA are opposite sides. There is no common point. And diagonal. The lines joining the opposite vertices of a quadrilateral are called the diagonals of the quadrilateral. In the figure ABCD, AC is the diagonal and BD is also a diagonal. Okay, so there are 2 diagonals in this quadrilateral. Types of quadrilaterals. Number 1, rectangle. A quadrilateral whose each angle is 90 degrees is called a rectangle. Both the pairs of opposite sides are equal. Means this side is equals to this side and this side is equals to this side. Okay. The diagonals of a rectangle are always equal. Means its diagonals are always equal. Number 2, square. A quadrilateral having all sides equal and each angle measuring 90 degrees is called a square. All the sides are equal. Okay, in the figure, square MNOP, angle M is equals to angle N is equals to angle O is equals to angle P is equals to 90 degree. And also MN is equals to NO is equals to OP is equals to PM, means all four sides are equal and the diagonals of a square are always equal. Okay, diagonals are always equal. Construction of rectangles and squares. Example 1. Construct a rectangle ABCD in which AB is equals to 5 cm and BC is equals to 4 cm. Procedure. Number 1. Draw a line segment AB of length 5 cm. Now using a set square, draw perpendicular at A and B. 3. Using a scale, mark BC is equals to 4 cm on the perpendicular at the B and mark AD 4 cm on the perpendicular at A. Join DC, ABCD is the required rectangle. Example 1. Draw a square of side of 4 cm. Procedure. Number 1. Draw a line segment EF of 4 cm at E and F. E and F, draw perpendiculars using a set square. 3. Mark a point G on the perpendicular at F so that FG is equals to 4 cm. Also mark a point H on the perpendicular at E so that EH is equals to 4 cm. And thus EFGH is the required square, right? Let's do the exercise. A triangle has dash sides and dash vertices. A triangle has 3 sides and it also has 3 vertices. The sum of all angles of a triangle is 180 degree. Right, students? Now you will do practice of the remaining questions.